segment, I will try to show you how to use raw data to construct the stem and leaf display. The only thing that you need to remember is that stem and leaf display is utilized only for a two-digit number like 21, 32, 45, 69, 18 and so forth. Also, you can use decimals such as $4.50, $7.30, $3.50, $6.60 and so forth. In this example, I am going to use age for people that work in a particular company X. So the age group is provided for the people that work, the lowest number being 22 and the highest number being 65. The way we're going to break up this data is first we have to construct this vertical line called the stem. On the left hand side would be all the numbers. On the left hand side of the column you have the stem, and on the right hand side of this vertical line will comprise of what are called leaves. And what it enables you to do is it can give you a quick idea as to what the concentration of this data set is. So since the lowest number is 22, I'll start with 2, 3, 4, 5 and 6. And let's look at the table and see how many numbers start with 2. We have 22, we have 29, we have 27, we have 25, as we go down 23 and 27. Do not worry if they are repeats, because the more repetition you have, the better it is for you. So on the right hand side of this vertical line, I'll post these numbers: 2, 9, 7, 5, 3, 7. So how many do we have associated with 2? 6. 2, 9, 7, 5, 3, 7. Similarly, we can look at the numbers associated with 3. We have, let me do it in blue. We have 35, 31, 39, 33 and 39. So again, I do put the number, make sure they are all in the same column, which makes it easy for your eye. So the first number in this case would be, let me 35. So 5, 1, 9, 3 and 9. In a similar fashion, if we go down the list, 45 only, the 45 only occurs. Here we have 45 and here we have 45. We have two 45s. And it doesn't matter if it repeats. Then we look at how many numbers start with 5. Five would be 52. Oh, I'm sorry, it's 53, 57 and 52. So we have 53, 57 and 52. And finally going down to 6, let's see how many numbers are associated with 6 or starts with 6. Let me use a different color. Use black. The first number is 63, then 62, then 62, and then 65. So when we go down the tree, when we construct this, the stem and the leaf, this will give you 3, 2, 2, 5. So what do we get from this by looking at this graph? We can tell for sure that the people that work in this company, the majority of the people are in their 20s, because that has the highest frequency. Which group has the second highest frequency? The people in the 30s. And which has the least frequency? People in the 40s. And in this case, both individuals are 45 years old. We can also look at this data and say what is the oldest person that work in this facility, 65, and also what is the age of the youngest person, it's 22. So we can get all this information just by looking at the stem and leaves, and that makes it so much easier. The next thing we're going to do is we're going to arrange this stem and leaves in an ascending order. So we'll keep the stem and the left hand, the vertical line and all the numbers left to it would be identical. Only the thing that's going to change would be the order of the leaves on the right hand side of this vertical line. So once we recreate this number 2, 3, 4, 5, 6, once we recreate, this is what you're going to have: 2, 3, 5, 2, 3, 5, 7, 7, 9. Next one would be 1, 3, 5, 9, 9. Third one would be 5, 5. There was no change. The fifth one would be 2, 3, 7. And finally 2, 2, 3, 5. This makes it very, very obvious, and it's easy on the eye, and we can easily be able to identify the one with the lowest, which age group dominates the workplace and which age group has the least number of people. In this case, 20s dominate this workplace, whereas people in the 40s are the least. There are only 2 45s in this case. Now the next thing we're going to do is we're going to use this raw data to construct what is called grouped frequency distribution. Again, don't get scared, it's a big word, but it's good. So we will try to construct what is called group frequency distribution using the information that we have. In other words, all we will do is create a table. Create a table. And one of the things that we need to go on this table is the age group of the employees. So we put a line, we change the color, it's going to be age group, and the frequency. And we have learned from the previous lecture and also the beginning of this chapter how to construct the confidence, how to construct the interval, and we're going to employ some of these techniques that we have learned to construct the interval width or the class width. So we will use, we make the pen little wider, class width, also called interval width. Interval width. And again, this is quite subjective. There is no hard and fast rule. So long it's between 5 and 15, that's fine. That's typically, that's the convention, between 5 and 15. So here we are. So let's look at, so suppose we create the age group 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 through 69. And if you look at the stem and leaf display, we can quickly see how many people are in the range, in the age group 20 to 29. 6. 30 to 39 is 5. 40 to 49 is 2. Sorry, I lost you guys there. 3, 4. And once we add all these numbers up, this is 20. This is how much we started out with. So in essence, the raw data can be transformed into numerical data, which can also be constructed back into a frequency table. And from here we can also construct relative frequency or proportional distribution and so forth. So, this is a simple way of showing how the raw data can be visualized, can be interpreted so that it makes more sense. When we look at, instead of looking at all this bunch of numbers, we can look at the way the data has been presented and tabulated. Imagine if there is, instead of 20, suppose there were 65 numbers or 70 numbers. Would you rather look at 70 raw data, or would you look at a table like this? So for sake of convenience and brevity, we use this kind of construct. Thank you, and this should conclude this segment of the demonstration.